Cosmic luck. NASA's Apollo 11 moon quarantine broke down. A review of archives suggests that efforts to protect Earth from contamination by any organism brought back from the lunar surface were mostly for show. When the astronauts of Apollo 11 went to the moon in July 1969, NASA was worried about their safety during the complex flight. The agency was also worried about what the spacefars might bring back with them. 4 years before Apollo 11, officials had been concerned that the moon might harbor microorganisms. What if moon microbes survived the return trip and caused lunar fever on Earth? To manage the possibility, NASA planned to quarantine the people, instruments, samples and space vehicles that had come into contact with lunar material. But in a paper published this month in the science history journal ISIS, Dagmar Degroot, an environmental historian at Georgetown University, demonstrates that these planetary protection efforts were inadequate to a degree not widely known before. The quarantine protocol looked like a success. Dr. Degroot concludes in the study only because it was not needed. Dr. Degroot's archival work also shows NASA officials knew that lunar germs could pose an existential, if low probability, threat and that their lunar quarantine probably wouldn't keep Earth safe if such a threat did exist. They oversold their ability to neutralize that threat anyway. This space age narrative, Dr. Degroot's paper claims, is an example of the tendency in scientific projects to downplay existential risks which are unlikely and difficult to deal with in favor of focusing on smaller, likelier problems. It also offers useful lessons as NASA and other space agencies prepare to collect samples from Mars and other worlds in the solar system for study on Earth. In the 1960s, no one knew whether the moon harbored life, but scientists were concerned enough that the National Academy of Sciences held a high-level conference in 1964 to discuss Moon-Earth contamination. They agreed that the risk was real and that the consequences could be profound. Dr. Degroot said. The scientists also agreed that quarantine for anything returning from the moon was both necessary and futile. Humans would probably fail to contain a microscopic threat. The best Earthlings could do was slow the microbes' release until scientists developed a countermeasure. Despite those conclusions, NASA publicly maintained that it could protect the planet. It spent tens of millions of dollars on a sophisticated quarantine facility, the Lunar Receiving Laboratory. But in spite of all this beautiful complexity, there were just basic, fundamental mistakes. Dr. Degroot said. NASA officials were well aware that the lab wasn't perfect. Dr. Degroot's paper details many of the findings from inspections and tests that revealed glove boxes and sterilizing autoclaves that cracked, leaked or flooded. In the weeks after the Apollo 11 crew returned, 24 workers were exposed to the lunar material that the facility's infrastructure was supposed to protect them from. They had to be quarantined. The failures of containment were largely hidden from the public. Dr. Degroot wrote, emergency procedures for the lab, like what to do in the case of fire or medical troubles, also involved breaking isolation. This ended up being an example of planetary protection security theater, said Jordan Bim, a historian of science at the University of Chicago who was not involved in Dr. Degroot's research. The Apollo 11 astronauts' very return to Earth also put the planet at risk. Their vehicle, for instance, was designed to vent itself on the way down, and the astronauts were to open their hatch in the ocean. In a 1965 memo, a NASA official stated that the agency was morally obligated to prevent potential contamination, even if it meant changing the mission's weight, cost or schedule. But 4 years later, on return to Earth, the spacecraft vented anyway, and the capsule's interior met the Pacific. If lunar organisms capable of reproducing in the Earth's ocean had been present, we would have been toast, said John Rummel, who served 2 terms as NASA's planetary protection officer. The likelihood that such organisms did exist was very small. But the consequences if they did were huge, and the Apollo program essentially accepted them on behalf of the planet. This tendency to downplay existential risk, instead prioritizing likelier threats with lower consequences, shows up in fields like climate change, nuclear weapons and artificial intelligence. Dr. Degroot said. In the Apollo mission, officials were not just downplaying the risks, they were not transparent about them. Failure is part of learning. Dr. Bim said of the inadequate quarantine. Understanding what didn't work will be important as NASA prepares to bring samples back from Mars, a place much more likely than the Moon to harbor life. In the 2030s, NASA has learned a lot about planetary protection since Apollo, said Nick Bernardini, the agency's current planetary protection officer. It is building in protections from the start and holding workshops to understand scientific gaps, and it is already working on a Mars sample laboratory. The agency also plans to be straight with the public. Risk communications and communication as a whole is highly important. Dr. Bernardini said. After all, he noted, what's at stake is Earth's biosphere. It's hard to imagine the biosphere at risk from alien organisms, but the chances are not zero. Low likelihood and high consequence risks really matter. Dr. Degroot said. Mitigating them is one of the most important things that governments can do. One small step for man, one giant leap for moon microbes. Interpretations of risk and the limits of quarantine in NASA's Apollo program. Abstract. As NASA prepared to land astronauts on the moon in the 1960s, scientists and federal officials came to fear that they could bring lunar microorganisms back to Earth with potentially grave consequences for human, plant, and animal life. To prevent this back contamination, representatives from NASA and a network of federal departments and services developed a protocol to quarantine astronauts, equipment, samples, and spacecraft exposed to lunar dust. Yet NASA assured policymakers and an anxious public that it had implemented impermeable safeguards against the escape of lunar microorganisms. It thought in fact prioritized likely risks to astronauts over unlikely risks to American society. To a degree previously unknown, the Apollo quarantine protocol suffered from numerous containment breaches that would likely have exposed the terrestrial biosphere to contamination had lunar microorganisms actually existed. In the 1960s, a network of American scientists, officials, and civil servants mobilized to protect the Earth against extraterrestrial contamination. Their efforts, which consumed well over $100 million, confronted the possibility that NASA's Apollo missions to the Moon could expose the Earth to microorganisms from the lunar surface. This backward or back contamination, some feared, threatened the wholesale degradation of Earth's biosphere and perhaps a pandemic that rivaled the worst in human history. The quest to prevent back contamination rarely enters the historiography of the Apollo program, even as the biological dimensions of the space race between America and the Soviet Union receive increasing attention. The two most important publications that investigate the effort concluded that, overall, NASA and its partners effectively addressed the threat. Two articles written for a popular audience frame the back contamination issue as little more than an amusing sideshow to the real drama of the Apollo missions. 3. The Moon, after all, seems so obviously bereft of life. To imagine otherwise requires an intellectual return to the 1960s, when little was known about the possibilities for life on other worlds. Since the 17th century, assumptions that the solar system was widely inhabited, an idea known as the plurality of worlds, led astronomers to identify evidence for life on the Moon, Mars, and Venus. By the early 20th century, the most sensational of these ideas seemed implausible, or at least unprovable, and biologists temporarily refrained from speculating about extraterrestrial life. Yet midway through the century, biochemists proposed, echoing proponents of between America and the Soviet Union receive increasing attention. The two most important publications that investigate the effort concluded that, overall, NASA and its partners effectively addressed the threat. Two articles written for a popular audience frame the back contamination issue as little more than an amusing sideshow to the real drama of the Apollo missions. 3. The moon, after all, seems so obviously bereft of life. To imagine otherwise requires an intellectual return to the 1960s when little was known about the possibilities for life on other worlds. Since the 17th century, assumptions that the solar system was widely inhabited, an idea known as the plurality of worlds, led astronomers to identify evidence for life on the Moon, Mars, and Venus. By the early 20th century, the most sensational of these ideas seemed implausible, or at least unprovable, and biologists temporarily refrained from speculating.